Okay, so last week we finished up talking about stoichiometry, but we didn't get super far into it. Today we're just going to do a lot of practice. And I wanted to go back to the problems we finished up with on Friday. Specifically, this chemical reaction we had here with silicon dioxide and hydrofluoric acid. We said the first step anytime you're doing stoichiometry is to balance your equation. That's where you put the coefficient numbers in front of each molecule as needed. And in the first one, we saw you can do a mole-to-mole ratio to figure out how much of each reagent or product you would have given a certain amount of a starting material or product. And we did that a few different ways, but I want to take it one step further today, so I've got a third problem to add on. So this will be problem number 3, and we'll do a few more before jumping into our carbonates. All right, so the first one is how many moles of water are made when 2.44 grams of silicon dioxide react. And I'm going to go ahead and just redraw our chemical equation. We've got SiO2 plus 4HF goes to silicon tetrafluoride, SiF4, plus 2 water molecules. This one's a little bit more challenging, so try to figure it out on your own, and if you get stuck, check with a partner. I'll give you a hint too. Convert from mass to moles before doing a mole-to-mole ratio. All right, let's try doing this as a class. I tried to give you a hint to get you started, but anytime you're given something in grams, it's always a good idea if you're stuck to convert it to moles. It's really easy to convert from moles to anything else. So let's first convert to moles. We know we have 2.44 grams of silicon dioxide. We need to convert to moles, so I'm going to put grams of SiO2 on the bottom, and we want moles of SiO2 on the top, right? This way, when we do the conversion, we cancel out grams, and we're left with moles. Okay, so now the question is, what number goes where for SiO2, the gram to mole conversion?
So 1 mole at the top.
Yep, 1 mole of silicon dioxide. And then how do we figure out what number goes on the bottom? Yeah, so what you have to do, if you remember from last week, is you have to find the mass of silicon dioxide. So for example, we've got 1 silicon. We know each silicon weighs about 28.09 plus 2 oxygens, which are about 16.00 grams per mole. And when you add these together, you get 60.09 grams per mole. And now that we have this value, we can plug it in to go from grams to moles. So I'll just go ahead and plug in 60.09. Okay, so now we're in moles of silicon dioxide, but what we want are moles of water. So we need to cancel out moles of silicon dioxide. So I'm going to go ahead and do moles of silicon dioxide down here. That way the moles cancel out. We want moles of water be our final unit. So now we have to figure out what number goes where for this mole to mole ratio. What do you think?
1 mole of SiO2 makes 2 moles of that H2O.
Yep, so 1 mole of SiO2 makes 2 moles of water. We saw that from our balanced equation. So we plug in 1 on the bottom and 2 on the top. Now that we've done that, we can cancel out moles of silicon dioxide, We're left with our desired units of moles of water. So when I plug this into my calculator, I'm getting 0.0812 moles of water. Just like before, you do want to pay attention to sig figs. So in my final answer, I only had 3 sig figs shown. Does that make sense? Let's try another practice one. Hopefully we can get this one right off the bat. Problem number 4 is how many moles of SiF4 are made when 12.3 grams of water are formed. See a show of thumbs too if you think you got it. All right, it looks like we've got a fair number of people that have gotten it already, so let's go ahead and try to do this. Just like before, we always start out with what we know. We know we have 12.3 grams of water. That's the given unit. We need to get rid of grams and go to moles. So I'll put grams of water down on the bottom. I'll put moles of water on the top. Now the question is, how many grams of water are there for every 1 mole? In order to do that, just like before, we have to find the molecular weight of water. So I'll just do that down below. Molecular weight of water, we've got 2 oxygens, which is 2 times 1.01 plus 1 oxygen, which is 16.00. Whoops. Gives you a value of 18.02 grams per mole. So just like before, you can take this value, plug it in up here. We're getting 18.02 grams of water for every mole. And now we need to, after we've canceled out grams, we need to cancel out moles of water. So I'm going to put that on the bottom here. And our desired unit, if we reread the question, is moles of silicon tetrafluoride. So SiF4, and now the question is which number goes where? If you look back up at the chemical equation, for every 1 mole of silicon tetrafluoride you get 2 moles of water. So you do 1 to 2. Cancel out moles of water, you're left with moles of silicon tetrafluoride. So what answer are we getting out here? Anybody want to share? Okay, so 0.341 moles of SiF4, the silicon tetrafluoride. There we go. So this is one thing that always hangs students up is they see grams, they kind of mentally freeze. But if you're ever stuck, go to moles. Moles are the universal currency in chemistry. It's way easier to go from moles back out to something else. All right, got another one. This one's going to be our challenge, our first challenge one, and then I've got a second challenge one later. So problem 5. I'm actually going to move this up so that you can reference it. And then I'll move this mouse down. We'll talk about the mouse later. So for problem 5 is what mass of water is made when 2.33 grams of silicon dioxide reacts. I'll give you a minute to work on this. And if you look up here, this rough guide can kind of help you get going. So you want to start out going from mass of A, which is your silicon dioxide, convert that to moles, and then go moles to moles using the ratio, and then moles back to grams using a new molar conversion. All right, let's try to do this as a class, and then I'll have one more problem that we can do just to really practice. All right, so we'll start out with what we know. We know we've got 2.33 grams. And always be specific, right? 2.33 grams of what? Silicon dioxide. So we want to write that down so we don't lose track of which molecule we're talking about. So that's the first one. And during this conversion, we need to cancel out grams of silicon dioxide. So I'm going to put that on the bottom here. And we already calculated that previously. That was 60.09 grams of silicon dioxide for every 1 mole of silicon dioxide. So I'll put 1 mole of silicon dioxide up here. Now we've got our moles of silicon dioxide. We can easily convert this using a ratio. So I'm going to convert this right here. And we know we want moles of silicon dioxide on the bottom. And our ultimate goal is to find out something about water. So I'm going to put moles of water on top. Now the question is, what's the ratio of moles of water to moles of silicon dioxide? Looks like we've got 2 water molecules for every 1 molecule or mole of silicon dioxide, right? So it's a 2-to-1 ratio. In fact, I'm going to change colors here just to make it the same. Okay, so we've got 2 moles of water for every 1 mole of silicon dioxide, right? All right, now that we've got that, we need to convert from moles of water to grams of water. So I'm going to put moles of water down on the bottom. And we need grams of water on the top. So now this looks like a molar mass conversion, right? We need to find the relationship of grams of water for every mole. And we did that previously as well. We said for every 1 mole of water, there's 18.02 grams of water. Just like before, I always like to check that I've done all my canceling. So I'm canceling out grams of silicon dioxide here. Canceling out moles of silicon dioxide right here. Then I'm canceling out moles of water right here, and I'm left over with grams of water as my desired unit. Okay, so when I go ahead and I plug this into my calculator, I'm getting 1.40 grams of water. Does that make sense? So pretty tricky. Because there are so many conversions, the key is writing out all your units, making sure they're right side up or upside down as needed. And then making sure you don't flip grams and moles on accident. All right, I've got one more challenge one, and I like this one because it's a good biology problem too. This is a kangaroo mouse. It lives in Nevada and absolutely blows me away. It blows me away because it can survive without water. It's one of the only mammals I think we know of that can survive without water. It doesn't really sweat, because if it were to sweat, it would evaporate and lose a lot of that water. Instead, it's got these ears and a big long tail that actually radiate warm blood out, so it can cool itself that way. Does anybody know how it gets water then to survive? Through metabolism, right? When you metabolize glucose, one of the byproducts is actually water. So they just eat a lot of food. The byproduct of metabolizing that food is water. So let's take a look at the equation for metabolizing glucose. We've got C6H12O6 plus 6 carbon dioxides. Oh, sorry, that should be 6 O2s. I'm getting my equation messed up. So you metabolize using aerobic oxygen, and then you generate 6 carbon dioxides, and you get 6 water molecules out. So really they're just using glucose as a way to generate this water that they need for survival. Okay? So in this question, It's how much water in grams whoops. Is produced when 25.05 grams of glucose is metabolized. Glucose is the big guy right here. And I will give you a hint that the molecular weight for glucose, we did this previously, it was 180.16 grams per mole. And we also found the molecular weight of water recently, that was 18.02. Whoops, should be a big 2 grams per mole. So see if you can figure out how much water this kangaroo mouse is metabolizing when they ingest 25.05 grams of glucose. All right, let's do this really quick. So just like before, we always start out with what we know. We know we've got 25.05 grams of glucose, C6H12O6. We want to get rid of the grams, so I'm going to put grams of C6H12O6 on the bottom, and we need to go to moles. And just like up here, we said we know that there's 180.16 grams for every 1 mole, so we can do that gram to mole conversion. And now what we need to do is convert from moles of glucose to moles of water. And if we look back up at the equation, we can say, all right, there's 1 mole of glucose for every 6 moles of water. That's the ratio that we have. So we've got 6 moles of water for every 1 mole of glucose. And then last but not least, we can cancel out moles of glucose, or sorry, moles of water, and get grams of water. And we know that the molar conversion that we need is the same thing as the molecular weight for water, which is 18.02 grams for every 1 mole. So now we go through, double check our canceling. We're canceling out grams and grams, moles and moles, moles and moles, and we're left with grams of water, which the final answer I'm getting is 15.03 grams of water. Which is a little bit weird to think about, right? So this mouse, when it ingests about 25 grams of glucose, is producing 15 grams of water that it needs to survive. It's a very clever biological trick. Does that make sense? All right, so with the rest of the period, we're going to work on the carbonates lab. And I've got a rough guide because it's pretty common that students get confused with this. And so what I've done is kind of outline what you need for the first page. So for example, it's the part A just says describe the product in complete sentences. So what did it look like? It's pretty easy. Part B says write a complete balanced equation for this reaction. And if you remember, we had sodium bicarbonate plus hydrochloric acid, and then we've got a reaction arrow producing CO2, water, and sodium chloride. And then we need to add in those coefficients to make sure it's balanced. We always do that before we do stoichiometry. And then once we do that, it says calculate how many moles of sodium hydrogen carbonate or bicarbonate you placed in the beaker. So we know the amount we put in. That should have been recorded in your notebook. And then you need to use a gram to mole conversion to find out the moles of bicarbonate that you used. And then for D, it says, all right, once you know the moles of bicarbonate that was used, figure out the moles of sodium chloride that should be produced. And so that's the mole to mole ratio from your coefficients. And then the next one says, all right, once you know how many moles of sodium chloride you have, what does that weigh in grams? So you can use a mass to mole conversion. And then the last one's the trickiest, and we haven't seen this yet, but this is called percent yield. What percent yield is the mass you recover, so the actual mass you got, divided by the mass you theoretically should have gotten, which we just calculated above, times 100. So I'll give you guys a minute to work on this, but see if you can work through this with your lab partner or neighbor, and I'll just leave this up on the board so you can use this as a reference. If you finish this first one, I would recommend going on to the second reaction and third reaction, and if you can, even just knock out the complete lab report in class.
Is this, you want this one type?
No, you can do this all by hand and turn it in tomorrow in lab. And if you are still having trouble with it, let me know in lab and we can work on it a little bit in lab or after lab. I just want it turned in by tomorrow night.